Hello everyone, it's 1 p.m. Eastern and that means it's time to begin another of our monthly CoCoRaHS Weather Talk webinars. Thank you for joining us today. I'm your host Henry Regis. Running the technical side of our program is our own Noah Newman, and with us in our studio today is CoCoRaHS founder Nolan Duskin. We're coming to you live from the Colorado Climate Center here at Colorado State University in sunny Fort Collins, Colorado. For those of you who are unable to join us for our live broadcast, we'll be recording it for future viewing on our website. All of our Weather Talk webinars are sponsored by grants from the National Science Foundation and donations from listeners like you. Well, folks, during today's webinar, we're going to talk about the weather and climate of the Midwest. And we're starting a series here. The next 6 webinars, we're going to look at the different parts of the country, and it should be kind of exciting to see what the weather is and the climate is as we go around the United States. Well, many of you have lived or traveled to the Midwest, and you probably remember it being either very cold in winter, rather toasty in summer. You've probably seen snow, wind, tornadoes, fog, freezing rain. You name it. The Midwest sees just about everything in those elements. And well, we're in for a real treat today. We have climatologist Mike Timlin from the Midwest Regional Climate Center in Champaign, Illinois here to tell us about the weather and climate of this region in the country. A little background on Mike. Mike is a native of Chicago. He roots for all the Chicago sports teams. He attended the University of Illinois where he holds a BS in chemistry and an MS in atmospheric sciences. He's worked at the Cooperative Institute for Research in Environmental Sciences in Boulder as a climate researcher and the Department of Atmospheric Sciences at the University of Illinois. Now at the Midwest Regional Climate Center, Mike holds the position of Regional Climatologist, where he's responsible for monitoring climate across the region, designing value-added tools to support decision-making challenges of stakeholders, and being a resource on climate-related issues. Well, welcome, Mike. Thanks for being with us today. We're so glad to have you. I got a phone that keeps ringing here. Sorry about that. Before you start your presentation, why don't you tell us a little bit about how you became interested in climatology?
Well, I've always been interested in the weather, and while I was getting my chemistry degree, I took several introductory meteorology classes and really liked the classes, really enjoyed it, and ended up working as an undergrad for John Walsh, who became my advisor in grad school. So as I finished up my chemistry degree, I decided that I wanted to go into atmospheric sciences, and that's when I made that transition and went to grad school and started worked at the Weather Service for a year before I headed out to Colorado for about 10 years and then came back to Illinois.
Well, that's great. Hey, why don't you go ahead and start the presentation? I see you've got your slides up, and when Mike is finished, we'll start taking some questions. So Mike, take it away.
Okay, so you are seeing my screen then?
Yeah, it looks good.
Okay, great. Okay, well, just wanted to start out by thanking Henry and Nolan for giving me this opportunity to present the information, and thank you guys for all the work you guys do for CoCoRaHS. It's a great program, and it really helps out with a lot of things, being able to see what's going on those smaller scales because we have so many people that are volunteering to take those rain gauge measurements. So I also want to thank all the listeners for being here, and then today we're just going to talk about the climate and the weather of the Midwest U.S. So we're going to jump in here and get going with some things here. As Henry said, we're at the point in the seminar series here where they're going to get started with the different regions around the country. There are 6 regional climate centers around the U.S. They're funded by NOAA, but they're housed at universities around the country. Ours is in Champaign, and we cover a 9-state region in the Midwest. So we cover from over here in Minnesota, Iowa, Missouri, Wisconsin, Illinois, Michigan, Indiana, Ohio, and Kentucky. That's the region that we're going to be talking about. When you talk about the Midwest, a lot of times doing regional things, sometimes there'll be states out here to the west to be included, sometimes Kentucky's not included, sometimes Ohio's not included in the Midwest. Just kind of depends how you break down the Midwest, but for the purposes of these seminars, we're going to go with these 9 states for our Midwest region, and then when the other RCCs cover their regions, we won't be overlapping too much. So just a little bit about the geography of the region. We don't have a lot of mountains in the Midwest. We have a lot of mountains out here out to the west. We have the Sierras and the Rockies out here, the bigger mountains. We have some smaller mountains out here in the Appalachians. Those kind of cut into southeast Kentucky a little bit, but for the most part, we don't have a lot of mountains. That's not to say we don't have any relief at all. We do have, along the southern part here, we have some higher areas there, and then also up in the northern parts of the Midwest. So it's not just flat farmland everywhere across the Midwest, but we don't have a lot of mountains. So one of the biggest features in the Midwest is the Great Lakes. These 5 Great Lakes are the biggest lakes in the United States by area and volume, and it's not even close. They're far and away the biggest. Lake Superior is the biggest, and Lake Michigan and Lake Huron, Lake Erie, and Lake Ontario. Lake Ontario is a little bit outside the Midwest, but when we talk about the Great Lakes, I'll mention it a few times as we're doing a few things here. Not only are these, oh, I'm sorry, going someplace else. I'm sorry, I'll get to that in a little bit later. We also have a lot of major rivers in the Midwest. So this is the navigable waters in the Midwest. So the Mississippi River comes up here from New Orleans, and the Ohio River comes off this way all the way up to Pittsburgh. The Missouri River splits off, goes over here to Kansas City and up through Omaha. The Mississippi River goes all the way up here to Minneapolis, and then the Illinois River comes up here to Chicago. It didn't quite connect to Lake Michigan, but it's been engineered to do that. So the Chicago River was reversed so that you can actually connect down the Illinois River from Lake Michigan now. There's a lot of big cities in the Midwest. So these are the metropolitan areas that are over 1 million in population. That's Minneapolis, Kansas City, St. Louis, Milwaukee, Chicago, Indianapolis, Cincinnati, Columbus, Cleveland, and Detroit. Amongst these, there's several of these. Cleveland, Detroit, Cincinnati, St. Louis, and Chicago have been among the top 10 biggest cities in the country at different times in the past. Mostly in the 1900s. Right now, Chicago is the only one that's in the top 10 cities in the country as the population has shifted more to the south and to the west in the country. Like I said, it's not just farmland in the Midwest. We actually have quite a bit of forested land, especially in the southern parts of the Midwest and up here in the northern parts of the Midwest. So quite a bit of forested land. We don't typically get the large, long-lived fires like you hear about out west when you have the wildfires. But despite that, we actually have had some bigger fires. 1871 was a big year. There was the Peshtigo fire in Wisconsin, the Great Michigan Fire up here in Michigan, and as a matter of fact, the Great Chicago Fire was that same year. So Henry mentioned that we get a lot of variable weather in the Midwest. We get a little bit of everything, and part of the reason for that is that we can get air masses coming from a variety of different places. So because we're in a temperate zone, we kind of experience all 4 seasons. We get to deal with that. We get a lot of variation within the seasons as well as these different air masses kind of battle back and forth, and the weather is coming from different air masses. So we can get anything from the Arctic air masses coming down from the north. We can get dry continental air masses coming from the southwest. We can get moist air coming up from the Gulf of Mexico, and that tends to come in here. It affects more of the southern and eastern parts of the Midwest. And then these air masses that are coming from the Pacific will come in, but they're strongly modified by going over the mountains. So we're not really experiencing those as a maritime air mass when they come in from the west. But so we have a wide variety of air masses that can come in and affect us. Just to kind of give you an idea, even coming in here from the northeast, Superstorm Sandy that came into New Jersey came in and punched its way in from the east and had really strong winds over here over the Great Lakes and everything, so we can get storms coming in from that direction. We have remnants of hurricanes. Sometimes they'll come in here to Louisiana or Texas, and then they'll track up over the Midwest, and we'll get prodigious rainfall amounts from those, even though they're not hurricanes anymore. Just from the remnants of them, they're still pretty good rain producers. So when we talk about the weather and the climate, we need to measure that somehow to have that evaluation of it. So what kinds of things are we measuring when we talk about weather and climate? Most of these we all know pretty well. Precipitation, we'll talk about rain and snow. We'll talk about the temperature. Measures of humidity. A lot of times we use relative humidity, which is a measure of how much moisture is in the air relative to how much could be in the air at the current temperature. That's one way of measuring. Another way to measure is to look at the dew point temperature, which is kind of going the other direction, saying with the amount of humidity that's in the air right now, what would we have to cool off the air to what temperature to get saturation? So get a cloud to form, basically. So that, again, gives us an idea. We'll talk about dew point most in this talk, and the reason for that is that it doesn't vary as much throughout the day. Just the diurnal temperature ranges from the morning to the afternoon. You'll get a big change in relative humidity just because the temperatures change, even though the moisture is staying the same. So we'll talk about it from the point of view of the dew point. In the Midwest, the dew point also is a great forecast tool, and that if other things are held steady, if the dew point's not going to be changing, that'll give you a pretty good idea what the overnight low temperatures are likely to be, because the temperature will fall to that dew point temperature, and then it's really hard to drop below that because it has to basically has to condense the water out of the air in order to get cooler than that. I'll talk about pressure. That's one of the ways to measure what's going on, how much air is stacked up above you, basically. The differences in those pressure will create winds, and so that's another thing that we'll keep track of, the wind speed, wind direction. Clouds, and sometimes we'll just look at how much sunshine there is as opposed to looking at the clouds, but they're kind of complementary to each other there. And visibility, which is how far you can see in a horizontal direction. So the first thing we want to look at is the precipitation, and we're looking at the precipitation and how that varies across the region. You can see that we get a pretty good gradient from the southeast down here, where we have more than 50 inches of annual precipitation, all the way up here to northwest Minnesota, where it's less than 25 inches. So quite a range of precipitation values just across these 9 states. If we look at that for January, we can see that down here in southeast Kentucky, we're at about 4 inches, and then we get back up here to western Minnesota, it's about a ½ inch. So really big difference in the wintertime. Summertime, we don't have quite that kind of variation. It's about 2½ inches in parts of Michigan, up to as much as 5 inches when you get out here into Missouri or Kentucky. So much less of a gradient, though, in the summertime precipitation amounts. So next thing I want to look at is try to look at other months. So rather than show you 12 monthly values like this, we're going to look at Minnesota, Minneapolis right up here, and we're going to look at Louisville, Kentucky, which is down here. And we'll look at what the precipitation looks like throughout the season. And you can see there's a very strong seasonal cycle. If we're up in Minneapolis, we go from less than 1 inch of rain to more than 4 inches of rain in the summer months. In Louisville, we have a little different situation. It's more steady, and I should note that the scale here is a little bit bigger too. So this 4-inch line here is the same as this 4-inch line here. But we go from here 3.5 inches maybe as the smaller months, and up to about 5.5 for the wettest months in Louisville. So much less of a seasonal cycle in the precipitation amounts. If we look at the daily amounts, this is just looking at the 2015, just looking at 1 year. These are the daily amounts of rainfall, and you can see that seasonal cycle. You can see the difference here, where it's drier in the wintertime and wetter in the summertime in Minneapolis. If we look here, there's about 6 days that were above 1 inch. Again, the scale is different here for Louisville, but you can see a couple different things. One, that the precipitation is spread out throughout the year much more than it was in Minneapolis, and there's an awful lot of days. The 1-inch line there actually isn't a line here, but if you look here, there's an awful lot of days here that are over 1 inch of rain. So getting 1 inch of rain happens a lot more often as you go down to the southeast. The other kind of precipitation we get in the Midwest is snow, and we have a huge variation in snow. Down here, we get less than 6 inches in the boot heel of Missouri. As a matter of fact, across the southern part here, it's less than 1 foot of snow is the annual snowfall. As you go north, it increases, and then pretty much just north to south gradient until you get up by the lakes, and then we get a huge increase on the downwind areas from the lake. And so here we're picking up these red areas up here are 8 feet or more of snow for the year. So quite a contrast from the south to the north here. As a matter of fact, up here we're talking 10 to 12 feet of snow on this peninsula that juts into Lake Superior. So we'll talk a little bit more about the lake effect snow later. Temperatures, get a gradient mostly from south to north, the warmer temperatures to the colder temperatures. look at that throughout the year. In this case, we're going to be looking just at Indianapolis, but we can see typically what we look at are the minimum and maximum temperatures. So January minimum temperatures in Indianapolis are about 20, about 35 for the high. You get into the summertime and you're about 65 for a low and about 85 for a high. So get a pretty good contrast in what's going on there. What we'll look at next is we're going to take this red line and this blue line and we're going to transfer those onto this next plot where we're going to actually look at daily values. And you can see basically the same curve for the minimum temperatures at the bottom of the green, and here's the curve for the normal maximum temperatures at the top of the green. But we've added a lot more information on this graph, and so this is called a thermograph. And what we have on here is the extreme temperatures. So here we can see that the extreme values for the minimum temperature and the extreme values, so these are the records, the record warmest day and each day of the year as you go through for Indianapolis. And then the other thing on here is these little bars, and these bars show the daily temperatures for 2012. And that was a year that we had a very warm spring, so here's a bunch of times that you can actually see that this is the year that those records were set. Same thing here in the summertime. A few things we can see, the range of temperatures is much bigger in the wintertime than it is in the summertime. That's pretty typical in the Midwest. For the extremes, the normals are actually just the opposite. The normals are about 15 degrees range here and about 20 degrees here in the summertime. So we get a little bit different situation with what's going on. We have a lot of days in the wintertime with a really small range of temperatures during that day. In the summertime, it's pretty typical to have a pretty good range from the high to the low. Okay, the dew point temperatures, again, similar to what the temperatures are mostly in the Midwest here. We're going to see a variation where they're going to see higher dew points in the south and the lower dew points as we get further north. Looking at winds, this shows 4 months, so we're going to show March, June, September, and December, and these are near surface winds basically, and this is actually modeled data just to get this plot made, but it would look about the same if we did this with actual observed data as well. The windiest time is actually in the spring in the Midwest. It's also windy through the winter time, and we get into the summer here in June, the fall, and September, we see a lot less wind, especially to the southeast. Looking at clouds, one of the things we'll see is a lot of cloudiness over here once you get over by the lakes and downwind of the lakes. So the air coming over the lakes will actually help enhance the cloudiness, and so we'll get a lot of cloudiness over here. A lot of times, especially in the winter time, that's really an effect that you'll see a lot, that the relatively warm lakes will help create clouds, and you'll have a lot of cloudiness around the Great Lakes. So the climate affects a lot of diverse areas of the economy. Agriculture, which is really big in the Midwest. It also affects a lot of transportation. There's a lot of large urban areas and forests. I'm going to kind of give a little bit more information about those first two in particular here. And talk about agriculture in the Midwest. Some people think this would be the only slide you need to show. It's corn and soybeans. If you're from the Midwest, you drive along the highways, there's corn and soybeans. Seems like they're everywhere. But there's a lot more going on in the Midwest as well. So I want to talk about some of those things as well. But here's the areas where corn is harvested, and basically it's how many acres of corn for each dot. And so you can see this 9-state region encompasses a pretty good area of that corn belt. Soybeans, same kind of thing. This 9-state region, again, is going to pretty well overlap with that soybeans. There are soybeans out here further west and down to the south as well, somewhere on the coast, but a big part of the soybean crop is from the Midwest. But there's a lot of other things going on as well. There's dairy cattle, and that's a lot of big thing in Wisconsin. You went here, it's a dairy state, so that's not surprising that there's a lot of dairy going on there. Beef cattle all across the country, but there is a significant part, especially in the southwestern part over here and in Kentucky. It's a lot of beef cattle as well. Hogs and pigs. Iowa is actually kind of the biggest state for pig farming. That also goes in through here, Missouri, Illinois, Indiana, into Ohio. Some also went down here in North Carolina, but Iowa is the state for pigs. Horses across the country all over again as well, but that's a big industry in Kentucky. So talking about some of these places that have the #1 state. So Iowa is the #1 state for growing corn for grain. It's not sweet corn that you eat, it's corn for grain. Also soybeans. They're also number one in pigs, and they're also number one in producing eggs. So Iowa is a really, really important state. Their agriculture overall for all their crops is over $30 billion a year, so it's a very, very big part of the economy in Iowa. Looking at some other things, cranberries, the number one state for cranberries is Wisconsin. Number one state for turkeys is Minnesota. Number one state for pumpkins is Illinois. As a matter of fact, almost all the pumpkins that are produced, that are processed and canned, are grown in Illinois. Ginseng root, about 90% of the ginseng root is grown in Wisconsin, actually just in a few counties in central Wisconsin. Tart cherries, number one state is Michigan, and blueberries is also Michigan. So a lot of crops have a very important presence in the Midwest. Transportation-wise, due to the central location, a lot of transportation, even if it's not the beginning or ending of the route, a lot of it goes through the Midwest. This is showing flight patterns and traffic and how many flights there are per day in different parts of the country, and you can see that this Midwest region has a lot of air traffic coming through here, so a lot of connecting flights through, and sometimes even flights over here can be affected if there's bad weather in the Midwest because planes will get held up and they won't actually make it over here so they can make that next flight. This is interstate traffic, so cars and trucks. Again, we have the same thing with that central location. We're looking at the Midwest here. We got a pretty good chunk of highways here, and a lot of, the thicker those lines are, the more traffic there is. You can see there's a lot of traffic through the Midwest. Rail traffic, same kind of thing. Chicago has been historically a hub of railroad travel, and Kansas City as well. So there's a lot of traffic through here. Some of that is due to agriculture, some is due to the auto industry, parts going in and cars coming out of Detroit. And then the other thing is navigable water. Sorry, I struggle to say that. But that's both on the Great Lakes, so we have a lot of shipping on the Great Lakes. So the Great Lakes actually connect to each other and all the way out down the St. Lawrence River here out to the Atlantic Ocean. So there's ocean-going vessels that actually come into the Great Lakes. There's shipping of iron ore down here to steel plants. There's shipping of automobiles from Detroit. So there's a lot of stuff going on here. About 40% of the shipping on the Great Lakes is tied to iron ore and steel, either inputs or outputs of the steel industry. Another 40% is tied to agriculture. Also, we have a lot of the major rivers up here, so navigation up from New Orleans up the Mississippi River, Ohio River all the way up to Pittsburgh, the Missouri River over to Kansas City and up past Omaha. The Mississippi River, the upper Mississippi River, goes all the way up to Minneapolis, and the Illinois River, which goes up to Chicago and actually connects to the Great Lakes. And there's a lot of agricultural products that are shipped on barges on those rivers. So I'm going to talk a little bit more about the Great Lakes. Like I said, they're the 5 biggest lakes in the U.S., and that's whether you do it by area or volume. And these lakes are huge, not just in the U.S., but actually in the world. So these are some of the biggest lakes in the world. Lake Superior is actually the biggest lake in the world by area, freshwater lake in the world. The only lake that's bigger than that is the Caspian Sea, which is actually salt water. So, and all 5 lakes rank among the top 20, whether it's by volume or area in the world. So they're very big. About 95% of the fresh water in the United States is located in these lakes. About 20% of the world's freshwater that's sitting in lakes is in these 5 lakes. So it gives you an idea how big they are. For those of you that aren't from the Midwest, don't really grasp how big these are. Lake Superior is about 350 miles long and about 160 miles wide. Lake Michigan's also really long, 300 miles long, about 115 miles wide. Lake Huron over here is about 200 miles long and 180 miles wide. Lake Erie is about 55 miles wide, but 240 miles long. And Lake Ontario is about 50 miles wide and 190 miles long. And they're very deep. So Lake Superior goes more than 1,300 feet deep. Lake Michigan more than 900 feet. Lake Huron about 750 feet. Lake Erie is more than 200 feet deep at its deepest point. Lake Ontario is more than 800 feet deep at its deepest point. So very, very big, very deep lakes. And just to kind of give you an idea of some of those distances, Philadelphia to Boston is 300 miles Dallas to Houston's 240 miles, and Phoenix to Las Vegas, 290 miles. So it kind of gives you an idea just how big those lakes are. If we compare the lakes themselves to states, Superior is about the size of Maine or South Carolina. Lake Michigan is roughly the size of West Virginia. Lake Huron also about the size of West Virginia. Lake Erie is roughly the size of Maryland. And Lake Ontario is roughly the size of New Jersey. So that kind of gives you an idea just how huge these lakes really are. So because they're so big, they actually affect the weather much like an ocean would. So kind of like an inland sea is what they're sometimes referred to. So they have a lot of impacts on the weather. They also have tons of shoreline. So Lake Ontario has about 700 miles of, or I'm sorry, Lake Ontario has 700 miles of shoreline. Lake Huron has about 3,800 miles of shoreline. So that's another thing that comes into play there with the lakes. So one of the things that happens is that there's a big contrast between the lake temperature and the land temperature. So this is a summertime situation where the land would be much warmer. The reverse would happen in the wintertime. But you get a colder temperature over the lake and warmer temperatures over the land, and so you set up these lake breezes, and it's much like a sea breeze that you get along the coast and the oceans, but same kind of thing happens. You can get a convergence zone, you can create some lifting here that can create clouds, it can create precipitation. So those lake breezes can have an effect, and these near lake areas are usually much cooler in the summertime and actually warmer in the wintertime than areas further inland away from the lakes. One of the things that the lakes also affect is something called chilling hours, and this is really important for a lot of plants, perennial crops like fruit, that only bear fruit if they get enough chilling hours in order for them to set up their fruit for the following year. So they have to have this over the wintertime. And we see a big difference over the lakes. So as you go over here to Minnesota, you have far less chilling hours. So these are, chilling hours are the hours between 35 degrees and 45 degrees. And so you accumulate those throughout the wintertime, and then if you had enough, then hopefully you'll be able to bear fruit. You get a lot less of those over here in Minnesota because you're either much warmer than that or much colder than that. So you just quickly go through those transition seasons. Over here by the lakes, you get a lot more moderated temperatures. So in those spring and fall seasons, you spend a lot more time between 35 and 45 degrees, and so you pick up a lot more chilling hours. That's really important, like I said, for the fruit industry, and that's why you have a lot more fruit grown over in Michigan. Another thing, plant hardiness zones, we can see the effects of the lakes on that. You can see for the most part where you have just a north-south gradient as you're going from one plant hardiness zone to another in the eastern two-thirds of the U.S., but when you get over here by the lakes, you see some really big differences. And if you zoom in here, you can see how drastically different that is. So you're getting things that are, these green areas are similar to what, let me back up here, green areas are kind of like Missouri, southern Illinois, Kentucky kind of areas, and oops, looked the wrong way. So when we zoom in, you can see that similar plant hardiness zones are all the way up here along the lakes, extend well north of where they would be otherwise. And you can see how the transitions are here. And even here, what we'd have in northern Illinois or northern Indiana, we see the same plant hardiness zones all the way up here along the edges of the lakes, far north of where they would otherwise be without the lakes being there. Talked about the snowfall, and this is the same map we showed earlier where we have these huge snowfall amounts, annual snowfall amounts up here by the Great Lakes. And we'll go ahead and take a look at the mechanism of how that happens. This is called lake effect snowfall. And what happens is you have really cold air and it's going across the land cools off, it could be really cold, but as long as this water is not frozen, it's at least 32 degrees. So you can have a really big contrast in this air moving across in this relatively warm water. And what that does is it pumps moisture and heat up into the atmosphere, and that destabilizes the air and leads to it rising, and we'll get cloud formation and even snowfall. Parts that come into play here is the size of the lake. So the wind speed matters, the direction the wind's blowing and everything, and the fetch across the lake. So coming across the Great Lakes, you can have this mechanism happening over, more than 100, 200 miles, sometimes even 300 miles across the lakes. And so you have a lot of time for this to build up. So it gradually builds up and you end up getting snow on the other side. So we'll look at a few scenarios here that you could get snow. Sometimes you get some really widespread cloudiness and snowfall that'll happen as you get the wind blowing across the lakes from the northwest here to the southeast. And so you pick up all this cloudiness as you're going across the lakes. Another scenario is that you can get something that blows along the long axis of the lake, and this kind of happens along Lake Erie, and that's when you hear about those big snowfalls in Buffalo. It can happen on Lake Michigan as well when you get winds coming straight from the north coming down. And you get some interaction here from the lake breezes, and so you get this formation of the clouds and the snow, and then the lake breezes will help concentrate that into a single band. So sometimes you'll get a widespread snow, and sometimes you'll get a very concentrated. Both of those are lake effect snowfalls. Just an example of more of the widespread snow, you can see how here, in the case this was earlier this year, there was just an inch or two of snow on the Wisconsin side, but over I think a 6-day period here, we picked up a foot or two of snow on the Michigan side of the lake. So that's the kind of enhancement you can get out of that snowfall. Here's an example of a concentrate where you got a snow band that really just walloped one area. So this is South Bend right here, and it actually took a hit here when they had a snow band, a 2-day snowfall total of over 3 feet of snow. And you can see how concentrated this is and how that one band is really just zeroed in here, is that if you just go a county or two off here to the west, to the east, or to the south, you're going to have snowfall amounts of only about an inch or two. So we're seeing a huge drop-off from the snowfall we see here to where we're seeing right here in this, where this band's set up. And in that case, the band just stayed in the same spot. So sometimes the band kind of drifts, but other times it'll just lock in on a certain spot, and you can really get some impressive snowfall totals. Looking at Rockford, which is in north central Illinois, comparing that to South Bend, and just trying to see how the difference, how the snowfall is affected by this lake effect. The snowiest winter ever in Rockford is about 74 inches. The snowiest winter in South Bend is 172 inches. So this is 6 feet of snow, and this is 14 feet of snow. So you're seeing a really big difference. As a matter of fact, there was a month in January where they got 86 inches of snow just in 1 month in South Bend. So that lake effect can make a huge impact. We talked about the Great Lakes affecting the weather, but the Great Lakes themselves are actually affected by the weather as well. So the lake levels are affected. Precipitation, runoff into the lakes, adds water to the lakes, and evaporation takes water away from the lakes. And because they're so big, there's a lot of evaporation that can make a big impact on the lake levels. So we can see here, this is Lake Superior, and this is Lake Huron and Lake Michigan. They're actually represented on the same graph here. And you can see that we had pretty consistently low lake levels all the way through here through 2013, and then we saw a big increase in 2014, 2015, and the big part of the reason for that was that we had a lot of ice on the lakes over those winters. So this is the early 2014, early 2015 when these values peaked up here. So we had a lot of really cold winters, you know, a lot of cold weather, consistently cold weather. The lakes froze up more than they had in many years. And so we had a lot of lake ice that cut down on the evaporation and helped raise those lake levels up. That also has a lot of impact on things like lake levels on the shipping and things like that. It can affect the fisheries as well, and both commercial and sport fishing are both billion-dollar industries on the Great Lakes, so those are really important as well. So if we want to look at the ice from 2014, this is in date in February. You can see what it looked like. This wasn't even the peak, but this is show you how much ice you can have formed on these lakes. So you can basically, in a really cold year, get pretty close to freezing over much of those lakes. A couple years later, this is this year. This is what it looked like on the same date. So you can see that there's quite a bit of variation from one year to another and how much ice is on the lakes. So some other weather events that are going on in the Midwest, and we'll talk about a little bit. Winter storms, summer heat and drought, flooding, severe thunderstorms that'll encompass tornadoes, hail, winds, and then also some non-thunderstorm winds. So we get some strong winds even without that. So blizzards. Basically, the definition of a blizzard, you have to have reduced visibility due to falling or blowing snow. So it doesn't actually have to be snowing. You can actually just get a ground blizzard when you whip up the snow from the ground. But the visibility needs to get down to about a quarter mile or less. Winds 35 miles an hour or more, and typically the Weather Service kind of likes to consider something a blizzard only if it's lasting for several hours, because you can have a transient event come through and pick up the winds or something, but we wouldn't necessarily call that a blizzard. So some of the historic blizzards in the Midwest go back to the 1913 blizzard. It was pretty widespread, very long duration. It lasted for more than 15 hours, caused more than 200 deaths, many on land and on the lakes. So, matter of fact, said at the bottom there, 19 ships were destroyed, 35-foot waves on the lakes, and that wasn't just one of the lakes, that was actually multiple lakes, and there were 60 to 90 mile an hour winds. I don't have any graphics for that one, but we do have another one. Is a Armistice Day blizzard. This was in 1940. This one, there was mild fall temperatures in the 50s, so we went from the mid-50s, dropped all the way down into the single digits within about a day. This one caused about 150 deaths. A lot of people were not prepared for this. 70 to 80 mile an hour winds. So the snow that fell drifted up to 20 feet. And this storm is basically blamed for destroying the apple industry in Iowa. There used to be apple orchards across Iowa, and most of them were destroyed by the sudden cold weather when it came in. 1967 blizzard in Chicago. My mom always talks about this one because she had 2 small kids at the time. But it was Chicago's biggest snow event at the time. 20 plus inches of snow, and I think it was like 26 inches, I believe. Temperatures were in the 60s just a couple days before that. There were about 60 deaths blamed on that. There at 50 mile an hour winds, 10-foot drifts on Midway Airport. Midway Airport's right in the city, so it's pretty impressive when you're getting drifts like that even in a city. More than 30,000 cars were stranded across the city, and more than 1,000 buses were stranded across the city. So big impacts. It took several days to dig out of that. 1978 blizzard, about 70 deaths due to that. 1 to 2 feet of snow. Winds in this one gusted all the way up to 100 miles an hour. So really, really strong winds, and that caused huge drifts that drifted all the way up to rooftops in some places. We also had really cold temperatures in this one, so we got all the way down to 0, so very cold. So also caused problems. 1999 blizzard, more than 100 deaths, and 30 of those were actually shoveling snow. So a couple of people died from exposure to the cold, but quite a few died heart attacks shoveling snow. $1.4 billion in damages overall. Got very cold behind this storm, so it got down to 20 degrees below 0 over a big area. And a few days later, actually, the Illinois state record of minus 36 degrees occurred in central Illinois and back end of the storm. There were 60 mile an hour winds. 1 foot snowfall totals were spread across several states and a big part of Canada. There were 20 some inches in Chicago on this one, and 300,000 people were stranded at the O'Hare Airport either for a number of hours and some of them up to several days. So big impacts there as well. Talk about ice storms. Another thing we can get is freezing rain. These aren't usually quite as widespread, but sometimes they can be pretty widespread. I'll talk about one case in 2009 that actually was pretty widespread across the southern parts of the Midwest. The glaze can build up, so that's the ice. So it falls as rain, but it lands on surfaces that are below freezing, and it freezes on contact. And so that ice just keeps building up. If the rain just keeps coming, if that lasts for a long time, you can get some really significant buildup, sometimes up to several inches. The weight of all that ice can damage trees, power lines, cause a lot of problems, and it can also make roads really treacherous to travel when you get one of these ice storms. So this is a map showing the areas, the number of days on an average that you get freezing rain. And so here's the Midwest, and you can see that a pretty good area of this. It's not uncommon to get 2, 3, 4, 5 days of freezing rain in the Midwest. So can be a problem as we get in here. So we talk about the Kentucky storm, what happened, and actually I should go back and say this actually kind of covered an area back here, Arkansas, Missouri, through Kentucky, southern Illinois, southern Indiana, all the way up into Ohio. So this was a really, really big ice storm. But there's a couple pictures from the Paducah Weather Service office. You can see how the trees just can't support the weight of all that ice. Zoomed in to get an idea of what that looks like, and you can see why those small branches can't support that kind of ice on them. Here's the amount of ice that built up, and you can see this tongue right through here was 1.5 to 2 inches of ice. So you can imagine how much that weighs to have 2 inches of ice built up on branches and power lines and things like that. Another thing we can deal with is heat waves. One famous heat wave was the Chicago 1995 heat wave. 5 straight days, over 90 degrees. Minimum temperatures never dropped below 70. Because it was in the city itself, the urban heat island helps magnify that, makes it even worse. It helps trap the heat in there. So it's actually probably a little bit warmer than where it is. We were taking the measurements for a weather station, which you try to expose to more natural settings. 2 days over 100 degrees with minimum temperatures that never drop below 80. So it's really, really oppressive heat. That lack of cool down in the nighttime is actually what's been attributed to a lot of the deaths, that people seem to be able to recover if they can get a few hours of cooler temperatures where their body can kind of shed that excess heat. But when that doesn't happen, that's a problem. And dew points were above 80 as well, so really oppressive humidity too. It's involved with that. Talking about some droughts in the Midwest, Dust Bowl droughts. There were several different years of drought in Midwest. This is showing the summer of '36, which is a little more concentrated on the Midwest than the plains. These are obviously a big factor in the plains as well. The 1950s also saw several years of drought. The worst one was probably 1954, which was centered around St. Louis. And then we'd look at the '88 drought was really kind of concentrated on the Midwest, and that had a lot of agricultural impacts. And then more recently, the 2012 drought, and this was also over the plains and not just the Midwest, but we had some extreme and exceptional drought in the Midwest, and quite a bit of, especially in the southern parts of the Midwest, but a lot of impacts from that as well. Flooding can affect the Midwest on various spatial and temporal scales, so we can get some smaller scale flooding that happens pretty quickly, or we can get some much more larger scale flooding that can last for up to months. So the range there is some urban flooding. Sometimes you get just a thunderstorm that just overwhelms the sewers and backs up water. You can get flash flooding where over a smaller drainage basin you're getting widespread rains over that basin, and the water all just builds up and comes into the creeks really quickly. Or you can get river flooding. I'll talk a little bit more about that. We've had some pretty significant floods in the Midwest. A few of them that I'm going to talk about, these aren't the only ones, but some of the bigger ones. This was 1913, this was in March, and this one really affected Indiana and Ohio in particular. So this area in here picked up, this is in about a week's time, picked up 8-10 inches of rain. And so a lot of rain in that area filled up the rivers really quickly. This is what the flooding looked like. Dayton was one of the areas that got hit really hard. So this is an inundation map of Dayton from the 1913 flood, and you see a lot of the city was underwater due to that. 1937 flood is kind of the flood record for the Ohio River, and this was a little bit longer time period, but we're looking at January precipitation totals. This light blue tongue in here is up around 15-16 inches of rain. So over a month, that's a really wet month. And so we picked up a lot of rain in the Ohio River Basin, and a lot of flooding. Some of the worst flooding that happened in the 1937 flood along the Ohio River. Cincinnati, that's the flood of record for Cincinnati. Lots of flooding here all the way.
Mike, is that a horse in the tree in that last?
Oh yes, I'm sorry. I guess I should have.
It's pretty interesting.
Now I don't know how. Yeah, I grabbed this poster from somebody, and I'm sorry, I don't remember who it was. But yeah, this picture, and I can't verify this, but they claim this horse was found up here a couple of weeks after the flood crest. So apparently he washed in and got caught in the tree, and as the floodwater came down, he had no way to get down. So interesting stuff that can happen in floods. It gives you an idea how high the water was, though, too. And like I said, the inundation area around Cincinnati, some really big areas that are underwater when you have these kind of flooding in major rivers like this. The 1993 flood was a big flood. This was Mississippi, Missouri River mostly. It's a little bit further west. This one had a lot of agricultural impacts. This one was really long-lived. This was pretty much from spring to fall. So this was a really long period that this was flooding. The river stayed up for a really long time. It cut off a lot of bridges across the Mississippi River, rail transport. The bridges were shut down as well. So there was a lot of places that you couldn't get things through. This also affects the shipping on the rivers. Of course, the rivers can be affected if there's a drought and the water level goes low. They can't put much on the river. But if the water level gets up high, they don't like to ship when the water level's high as well, because the rivers are flowing too fast, and you don't want to get barges outside the main canals and things like that. So this would kind of give you an idea of how much rain fell. This is a 6-month period in 1993 from April to September, and this is the excess moisture that fell. So this is saying that there was 15 to 20 inches of rain above normal over that 6-month period. So that's a lot of rain to absorb, and that's why those rivers all swelled and overflowed. And this is kind of what it looked like. So this is the actual river in this picture is back here behind this trees, and all this area is flooded, so you can see how this cuts off these main highways and things that you just can't get across there. Same kind of thing happens with the rail lines as well. This was a shorter-lived flood. This was a little quicker. This basically June of 2008. There was a lot of here. There's actually another pocket of rain over this way, caused some flooding over here in southern Indiana. But this rain over Iowa, 15 inches of rain in some locations, and it just swelled up that Cedar River, and as it went through Cedar Rapids, it just overwhelmed the city there. And so inundation map here, you can see how big chunks of the city are underwater in the 2008 flood there. And then just more recently, this past winter, we had a really, really wet December. It was particularly warm. All the states in the Midwest set a record for the warmest December on record, but they also was really wet. So we had early in the month, a lot of rain up Iowa, Wisconsin, Missouri, and then right towards the end of the month, the last week or so, we had a big rainfall event that extended up here through Missouri and into Illinois and into Indiana, 5 to 10 inches of rain all along here. So these little white dots in here are about 10 inches of rain that fell. So some really significant rains fell in just in a week's time. And so that basically flooded almost every river along this area was above flood stage. So we picked up lots of flooding down here, Missouri, Illinois, Indiana. Talk about severe weather. That's another thing that we have. A lot of times we think about tornadoes, we think about the high plains, but the occurrence of tornadoes actually bleeds well into the Midwest here. This orange area is areas that typically have at least one tornado within 25 miles per year. So when you think about that, that's not very far away to have at least one tornado each year on average. So it drops off as you get a little bit further to the north and to the east, but we still see tornadoes across all the states in the Midwest. Looking at hail, that is more concentrated out here on the plains, but we can get some significant hail events in the Midwest as well. And then wind, we actually have the wind concentration shifts a little bit further east, and so you get a big concentration here of number of days where you get a 50-knot wind, and so that's up over 60 miles an hour or up close to 60 miles an hour. So you're getting really strong winds here in these areas several times a year. Looking at the distribution of tornadoes, this is for the whole U.S., but it's pretty similar for the Midwest, that you kind of get this spring peak where you pick up a lot more tornadoes as you get into the spring months. But you do get tornadoes throughout the year. Same thing with looking at it by day. So this is, midnight through midnight, and you see a lot in afternoon into the early evening. That's really the peak of when most of the tornadoes hit. But we do see them all times of the day. Some of the historic tornadoes in the Midwest, the deadliest tornado ever was the Tri-State tornado in 1925. This one fell on my birthday, so I remembered that one when I heard about that when I was a little kid. That really stuck with me. But this tornado went about 235 miles path length. There were more than 2,000 injuries, 695 deaths, and it's still the deadliest tornado in history. Here's an outbreak in 1974. We're in a 24-hour period from April 3rd to 4th. 148 tornadoes in that 24-hour period. That altogether was about 6,000 injuries and 315 deaths in that event. And then more recently, this is just back in 2011, May 22nd, there was an F5 tornado that went right through the heart of Joplin, Missouri. And this was the most recent deadly tornado. There hadn't been a tornado that was this deadly in a while. So 158 deaths involved with 1,000 injuries. It went about 22 miles, and what you can see is it touched down just west of town and very quickly ramped up to an F5, which is the strongest tornadoes that we record, and it went right through the heart of town. And so because it was an F5 right as it went through the heart of town, and there wasn't a whole lot of time for people to prepare to do anything about it. Not that there's much you can do with an F5 tornado either. So lots of deaths in that case. Hail, this one kind of touched close to home for me. I was living in Tuscola, Illinois at the time, and I have hailstones in Tuscola. Hail fell for about 20 minutes, so it wasn't just a quick storm either. This is a quarter here in the middle, and a quarter is about an inch across, so it gives you an idea how big those hailstones are. I got home, I was actually at work, so I was half an hour away. I wasn't there for the hailstone the hailstorm, but when I got home there were still hailstones that hadn't melted 3 hours later. So kind of gives you an idea. And the yard, around my yard, the roof was destroyed, the siding was destroyed, the trailer I had in the driveway was destroyed. And the yard looked like somebody had walked around with a baseball bat and punched holes in the ground. So it kind of gives you an idea of what you can be dealing with when you're dealing with hail damage. And we get a lot of wind damage in the Midwest. In this case, we're going to show an example here. It was a derecho that formed near Chicago and held together all the way out to the east coast of the U.S. So this is different snapshots an hour apart as it's moving to the east. But you can see in the Midwest all the wind damage reports that we got out of that. So the line of storms moves very quickly, and then all the outflow from the storms themselves added together, you get 80, 100 mile an hour winds in some cases with situations like that. And then, as I said, we can get other wind events. So this is, again, the Armistice Day storm in 1940, and you see this low pressure system, and you get these really tight isobars wrapped around it. So there's a really big pressure differences, which leads to really strong winds, and so you can get some really, really strong winds here. Sometimes it's tied to, like maybe you might have blizzard conditions up here to the north of the low. You might have severe weather down here by these cold fronts, but the winds themselves can actually be a hazard as well. Another case that happened was 1975, similar kind of situation, a really strong low and really strong winds, and that was the sinking of the Edmund Fitzgerald. So there's even a song about that, so anybody that's old enough to remember that from the 70s and 80s remembers that song. And then this is a more recent one where we had a big low that bombed through here and came up through Minnesota and dropped really, really deep pressures, really wrapped those isobars around there and got some really strong winds. So some of these orange ones here are from thunderstorm winds, but all these yellow ones out here are actually wind speeds that occurred just from the winds blowing around the storm. So sustained winds 50, 60, 65 miles an hour. So this can be really damaging as well. And then just quickly talk about some freeze temperature. I know I'm running kind of long here. So freezing temperatures can also be a factor. Much of the concern with freezing temperatures is in the spring and the fall when you don't know if you're going to have a freeze, or you may not have a freeze for a while, and then you get another freeze event comes in. But just to give you an idea here, this is the last freeze in the spring. Typically down here it's not till April. Up in here we don't get that last freeze typically till May. So the northern parts of the Midwest, it's a little bit later. First freeze in the fall, here we're getting upper Midwest here, we get the first freeze typically will happen in September, and then most of the Midwest it's going to be actually in October, with a few places down here, not till November. So looking at one of the big freeze events that happened was 2007. This was a spring freeze, and one of the things about damaging freezes is they don't have to happen particularly late in the year. In this case, this spring freeze was not particularly late in the year. It was pretty close to the median date of the last freeze, but the problem was it was really warm in March, and so we're seeing the departure temperatures here. So we're seeing that it was about 10 degrees warmer than normal for the entire month of March, and so perennial crops had already started responding, started growing, budding out, and so there was a lot of things that could be damaged if there was a freeze, and unfortunately we had that. So from about April 3rd to 10th we had a really long period of freeze. I showed here the April 8th, which is probably about the biggest extent of the freezing temperatures, but we had really cold temperatures for several days, and many places didn't just drop below freezing for a couple hours, which can be damaging to plants, but some places drop below freezing for several days. And so on top of all that growth that started in March, having 3 days straight of freezing temperatures caused a lot of damages, billions of dollars damage. About $2 billion is what that is estimated to cause. Here's where the disaster areas were declared from that freeze event. Most of the southern Midwest here, and it actually extended even further down to the southeast, but you can see a lot of damages here in the southern parts of the Midwest. And then just extremely cold temperatures, so even just in the middle of the winter time, can also have some impacts on plants and also pests. So sometimes this will affect the spread of pests across the Midwest. If you get a really cold winter, you can kill off some of the pests, but unfortunately you also kill off some of the vegetation as well. So this is just an example. You can get temperatures up here in the upper Midwest of minus 40 degrees. You can get minus 20s in through here. The whole area can get below zero, probably down to about minus 10 or so in here. So those are some of the more extreme temperatures, but you can get really, really cold events in the Midwest. Okay, and I think that's kind of everything I had. So I've showed here a few links here. This is the link to the MRCC homepage, which is the Midwestern Regional Climate Center. We have a tool, we call it our application tools environment, where you can go in and pull off data you want for stations. You can get maps of the region. You can get all kinds of different hourly, daily data. We can get a lot of value-added products where you can find out when's the last time the temperature was over 90 degrees. There's all kinds of neat tools in there that you can play with and work. That's free. You can just get on and register yourself. This Midwest Climate Watch is something that we keep maps that show what's been going on over the last week, over the last month, that kind of thing. So we'll have a lot of maps monitoring the current climate, but we also do write-ups every week and every month. And we've been doing that since 2000. So we have a nice long history of 15, 16 years now of reports every week talking about what was going on with the climate in the Midwest. And so those can be really helpful to go back and read, try to put things in perspective of what was going on or see what was going on in another part of the region. And then our VIP program, we started this in the last few years, which is the Vegetation Impact Program. That's where those freeze maps came from. We've been doing a lot of stuff with frost freeze, the chilling hours, things like that, things of how the weather affects vegetation in the region because agriculture is so important in the Midwest. That's why we started doing that. So I think that's all I had, so I think I'll turn it back over to Henry and see how things
Thank you, Mike.
go from here.
Very, very nice presentation. We really appreciate that. Hey, these links that you're seeing on the screen, we will put those on our website and have those available for you to click on Mike's page. Mike, do you have a favorite time of year there in the Midwest? If you grew up there, is there a specific one that you have enjoyed?
I really like the fall. I enjoy winter. I don't think I could live someplace that didn't have winter. I like having all 4 seasons. My sister moved to Arizona, is trying to recruit me to move to Arizona, and I don't think that's ever going to happen because I enjoy the winter. But fall's really my favorite time of the year. I enjoy when it cools off and you get those crisp days. And
that's probably a nice time to visit for folks too that are coming from around the country.
Yeah, it's a great time to see the fall leaves, especially when you get up in the northern parts of the Midwest.
Well, we have a Midwesterner who was born there, Nolan Duskin, with us today. Nolan, do you have any questions?
Well, I do. I liked spring the most, and I liked spring because everything could happen, and because I don't know how often I felt, and I never knew this until I moved to Colorado and discovered that as stormy and severe as our weather could be here, I never had as many situations here where I felt as close to losing it all as I did in springtime in the Midwest and early summer, with particularly strong thunderstorms rolling in after sunset when you really couldn't see what was going on and what was coming, and sirens would go off. A lot of fear associated with those nocturnal storms, but also a lot of excitement, and it certainly enriched my experiences growing up in the Midwest.
Well, and even the daytime storms in the Midwest tend to have really low cloud bases and poor visibility, so you really can't see tornadoes. When you see footage of tornadoes, it's usually from out in the plains where it's a little drier, the cloud bases are a little higher, and so you can actually drive around and see those storms. A lot of times in the Midwest, they're rain-wrapped, and you really can't see them. They're hidden, so they kind of come out of nowhere, even in the daytime.
Yep, and I was close to a couple of really pretty bad ones and was within a few miles of one on my bicycle, thought about storm chasing on my bicycle, and then thought that was probably a really dumb thing to do, so I took cover instead.
I think that was a good decision.
I have one other quick question while other people are getting their questions together, and you showed that map of, I think it was July average precipitation, and it showed a maximum over northern Missouri, and ever since CoCoRaHS has been around with volunteer reports, we have seen time after time some of the heaviest rains of the summer falling across the northern counties of Missouri. Again, a summer phenomenon. What's going on there?
I know you're putting me on the spot. I'm not sure I can answer that.
Yeah,
I bet it's raining, Nolan. That's probably what's happening.
Yeah, that could be. Yeah.
And
Yeah,
something.
part of that's you're just pulling the moisture up from the south. You're getting those winds and you're pulling those storms in off the plains and stuff. So I assume it's just got to be some kind of convergence of that's going on there.
Yeah, and I don't
I
know if
noticed
it's.
at one point the 24-hour rainfall record was in Missouri for the United States too. So it's not a new phenomenon that you're seeing a lot of rain there.
Right. Thanks.
Well, here comes some questions, and if you do have a question for Mike, we've got a little bit of time left. Go ahead and type it in. If you'll put down your name and the state that you're located in, that would be great. Here's one from James. He did not include a state, but his question is a good one. How do you use CoCoRaHS data? And please discuss how relevant that data is to you. So a lot of our viewers today are CoCoRaHS volunteers. How is their data relevant?
Well, it's great, especially in the summertime, but all throughout the year. But especially when we get convective weather, there's a huge variation over a small area when you have thunderstorms. So you can get several inches of rain, and the other side of the county's maybe got a few inches, few tenths of an inch of rain or something like that. So those variations, we're able to see that. When we looked at the co-op network, the goal there was maybe to have a station in every county. There wasn't a real dense network. You could have thunderstorms that went between those stations, and you wouldn't even catch the maximum values. So having the CoCoRaHS data is wonderful. It's great snowfall as well in the wintertime. So snowfall doesn't vary quite as much over short distances in most cases. Sometimes it does along the lake, like I said, but having a lot of people doing those snowfall measurements is actually really, really helpful, because over time we've had fewer and fewer of the traditional stations that are actually still doing snowfall measurements. And so being able to look at the CoCoRaHS data for the winter and see the snowfall has been wonderful as well. When we look at things along the Great Lakes, that can be another thing. We have a lot of population along the Great Lakes, so there tends to be a lot of volunteers along the lake, which is great. So if you get into like Chicago or Cleveland, you can really enhance those products when you're trying to look at where the big rainfall, where the big snowfall events happen, because you can really zoom in and have a bunch of different readings. And the other thing that they're really great for, from a climatologist point of view, is that they're wonderful for being able to do quality control. So if you do get spread out stations and one of them has 8 inches of rain and none of the other ones have more than an inch, you kind of get suspicious of that. But when you're able to have multiple observations across the county, and you can see that where the rainfall values ramp up to that 8-inch value, you kind of get a little more confidence in it and say, hey, we really did have 8 inches of rain there, because we have a bunch of surrounding stations that had 4 inches of rain. And so it gives you a little bit more confidence in the data, and that can be really important so that those data values aren't thrown out because somebody thinks that they're erroneous.
And if you're listening in and you have friends or relatives in certain parts of the Midwest, and I'll let you know those right now. So southeast Missouri, southern Illinois, southwest Kentucky, and then along northern Minnesota, the upper UP of Michigan and northern Wisconsin, and then western Illinois. Those are areas we really could use CoCoRaHS volunteers. We have many in other areas, but these are areas we could really use folks. So if you know anybody who lives in those areas and would love to measure rainfall, boy, help us to sign them up. Okay, here's another question. This is from Natasha, and she has a family member who farms soybeans, rye, and corn. How can he best plan for weather in Minnesota during the El Nino year, and what source should a farmer use for long-term forecasts? So 2 questions there.
Well, what basically happens when you get an El Nino is, whether it's El Nino or La Nina, you're basically just kind of shifting the numbers a little bit. A lot of the impacts are actually in the wintertime, not necessarily in the growing season itself, but there are some impacts that go into the growing season as well. And right off the top of my head, I honestly don't want to misstate something and say something wrong, so I'm not going to actually specifically tell you which direction things go. But using the El Nino or La Nina is helpful in the sense that it might tell you that you're less likely to have an extremely warm or an extremely cold year. It's not necessarily telling you it is going to be warm or it is going to be cold, but what it does is it takes away some of the chances of having an extreme on one end of that scale. Doesn't make it impossible. If you look at the last strong El Niños, we had a product that did something similar to this. One of the biggest things that jumped out of that is if you compared each of those 5 events, you could average them all together and say, yeah, it looks like it's a little bit warmer in this area. But if you actually looked at the 5 events, 3 of them might be a lot warmer, 1 might be close to normal, and 1 might be colder than normal. So it's not a definitive kind of thing that you can say, hey, it's an El Niño, this is what's going to happen. It's more of a skewing things one way or the other. It might give you an indication. Like in a La Niña year tends to be more likely to have a drought in the Midwest. So maybe you decide to plant something that's more drought resistant, or maybe you just don't plant quite as many acres of a crop that is more sensitive to drought. So it might shift numbers a little bit. You're not going to completely say, oh, well, you know, there's going to be a drought, so I'm not even going to plant or anything like that. You're not going to say it's going to be a drought, so I'm only going to plant this one thing. But it does, you might shift the numbers a little bit one way or the other based on that information. El Niño is probably one of the most useful for long-term forecasting because it's pretty slow developing and it lasts once it's there. So you kind of know 6 months out roughly what you're expecting. Maybe not in the summertime. The spring is kind of a rough time to do forecasting for El Niño, but once that starts setting up, say in the fall, you kind of know you're going to have that through the winter. If you have a strong El Niño in the winter, you kind of know it's going to last partway into the spring, at least before it starts to fall apart. So that kind of gives you some longer term. There's some other indices that are useful. The NAO, the Arctic Oscillation is another one. But those fluctuate much more quickly, so it's much harder to get a long-term forecast out of that. They may be tied to specific weather patterns in a certain location, but it's hard to forecast those because you don't know what the index is going to be showing at a time in the future.
Thanks, Mike. We have another question here. Juanita lives in Tuscola, where you lived, and she witnessed the hailstorm that you mentioned. She was wondering how large an area did that storm encompass, and she doesn't remember hearing other towns with the damage that you guys had there. She's just curious about that.
There was other hail in other locations, but the storm itself that affected Tuscola actually started hailing just a little bit northwest of town and then drifted through town kind of to the southeast. So it didn't have a lot of impacts in other places. Where it did hail in other places, it wasn't as big. And probably one of the biggest things about that was the hail lasted for as long as it did. So it lasted for about 20 minutes. In my case, the house I was living in, the siding was damaged on 3 sides. The Scout building in town had damage on all 4 sides of the building. So the hail was falling long enough for the winds to shift and actually affect all 4 sides of a building. So obviously the roofs were affected when the hail's falling, but even breaking siding and windows and things like that on the sides of the houses because it lasted so long. But yeah, it really was pretty isolated there. So it was basically that one storm cell that, like I said, set up a little bit northwest of town and drifted to the southeast through town.
Well, Mike, thank you for taking the time out of your busy day to be with us today. This is a great webinar, and the first in our series of regional webinars on climate and weather across the country. So again, we thank you for being with us.
Oh, thank you for giving me the opportunity, and I'm looking forward to the other 5 regions as well.
Well, folks out there, we want you to mark your calendars, and please join us in just 2 weeks. That's right, just 2 weeks from today on Cinco de Mayo. That's Thursday, March 5th. We'll air the second in our 6-part climate series, and this time we'll look at the weather and climate of the plains with the interim director of the High Plains Regional Climate Center, Natalie Umflett. Natalie will give a great presentation. We'll have the sign up. Actually, you can sign up on our website that's out there now. And again, it's only 2 weeks from now, so it's coming up very shortly. Finally, when signing off today is a short survey. If you would take that, it'll pop up on your screen. That'll let our folks know how we're doing out there. And with that, we'll see you again in 2 weeks. This is Henry Regis for the rest of the CoCoRaHS headquarters team saying goodbye and have a great afternoon.